All right, so here we have question number 3 from October-November 2021, paper 3, variant 2. The topic is complex numbers. This question is worth 6 marks. So part A is saying that given the complex numbers u is equals to a plus ib and w is equals to c plus id, where a, b, c, and d are real, prove that the conjugate of u plus w is equals to u conjugate plus w conjugate. So first of all, we are going to find the complex number u plus w in terms of a, b, c, and d. So u plus w would be equals to a plus ib plus c plus id. So what we are going to do is add the real parts and the imaginary parts. So a plus c plus ib plus id. So a plus c plus taking I is common multiplied by b plus d. So b plus d multiplied by I. So a plus c is the real part and p plus d times I is the imaginary part. Okay, this is the u plus w complex number. So the conjugate of u plus w would be, just simply convert this positive sign into -1. So a plus c minus multiplied by b plus d times I. This is the conjugate of u plus w. Now we are going to find u conjugate. So since u is equals to a plus ib, so the conjugate of u is a minus ib. And since w is equals to c plus id, so the conjugate of w is equals to c minus id. Okay, so u conjugate plus w conjugate, this is supposed to be a minus ib plus c minus id. So a plus c minus ib minus id. We are adding the real parts and the imaginary parts. So a plus c, taking minus I is common, multiplied by b plus d. So this is exactly the same thing as saying a plus c, then minus multiplied by b plus d times I. Therefore, we have proved that the conjugate of u plus w is equals to u conjugate plus w conjugate. Then we have part B. Part B is saying that solve the equation, the conjugate of z plus 2 plus I times z is equal to 0, giving your answer in the form of x plus iy, where x and y are real. So first of all, what we are going to do is take z is equals to x plus iy. Okay, so in place of z we can write x plus iy. So x plus iy plus 2 plus I, the conjugate of this thing, plus 2 plus I times z, and since z is x plus iy, and this whole thing is equal to 0. Now here we can use the outcome of part A, a thing which we have proved in part A. This thing can be used over here. Since we have already proven that u plus the conjugate of u plus w is equal to u conjugate plus w conjugate. So here actually we just need to focus on this thing first, the conjugate of z plus 2 plus I. So z is basically a separate co-complex number, and 2 plus I is a separate complex number. Since we have proved that if we take z in place of u and 2 plus I in place of w, so this will be exactly the same thing as the conjugate of u plus w. Okay, this will be exactly equals to the conjugate of u plus the conjugate of w, which we have proved in part A. Okay, so in place of this whole thing, the conjugate of x plus iy plus 2 plus I, what I can say is that this is exactly equals to conjugate of x plus iy plus the conjugate of 2 plus I. Okay, and then we have 2 plus I multiplied by x plus iy. So 2 times x is 2x, and then 2 times iy will be 2yi, and then I times x. So this is xi, and then I square y. So y multiplied by I square, and this whole thing is equal to 0. So now the thing is that the conjugate of x plus iy will be x minus iy, and the conjugate of 2 plus I will be 2 minus I. 2 minus I. Okay, plus 2x plus 2yi plus xi plus, and instead of I square we can write minus 1. So y times minus 1, and this whole thing is equals to 0. So x minus iy plus 2 minus I plus 2x plus 2yi plus xi minus y is equal to 0. Now, first of all, what we need to see is what are the terms which are actually without I, and what are those terms which are with I. I mean, it is exactly the same thing as saying that separate the real parts and separate the imaginary parts. So if we just focus on the real parts, so the real parts would not be having any x over here. Real parts would not be having any x over here. So what we can say is that x, ignore this, minus iy, then we have constant term 2, ignore this, minus I, then we have 2x, ignore this 2yi, ignore this xi, and then we have minus y. This is the real part. And then if we talk about the imaginary parts, so first of all, we can take this minus iy, so minus iy, and then minus I, and then 2yi, and then xi, and this whole thing is equals to 0. Okay, so as we can see that simplifications are possible over here. Okay, simplifications are possible over here. So this is 2x plus x, which will be equals to 3x. Okay, this will be equals to 3x. So 2x plus x is 3x, and then 2 minus y, 3x plus 2 minus y, and we need to see if any simplifications are possible. Yeah, this simplification is possible. 2yi minus iy, these two can be simplified into positive iy, then minus I, and then plus xi. No further simplifications are possible now. Okay, so far we have achieved this thing. Now we just need to solve this equation, and the real part is also equal to 0, and the imaginary part is also equal to 0, because on the right hand side of the equation we have 0. Okay, so the real part is 3x plus 2 minus y. Okay, and then take I as common, so multiplied by y minus 1 plus x, and this whole thing is equal to 0. Since the real part and the imaginary part both are equal to 0, we can actually form two equations. The first equation would be 3x plus 2 minus y is equal to 0, and the second equation would be y minus 1 plus x equals to 0. So we have two simultaneous equations. So y is equals to 1 minus x, and if we make y the subject over here, so, or we can say that if we substitute this equation into this first equation, okay, so 3x plus 2 minus y is equal to 0, and in place of y I can write 1 minus x, and this whole thing is equals to 0. So 3x plus 2 minus 1 plus x is equals to 0. Therefore 3x plus x is 4x, 4x plus 1 is equals to 0. Therefore x is equals to negative 1 over 4. The value of x is negative 1 over 4, and the value of y would be y is equals to 1 minus minus 1 over 4, which means that 1 plus 1 over 4, which is supposed to be 5 over 4. Therefore, what we need to do is we need to give our answer in the form of x plus iy. So minus 1 over 4 plus 5 over 4 times I. This is supposed to be your final answer. This was question number 3. All right, so here we have question number 4. Partial fractions. This question is worth 5 marks. Express 4x square minus 13x plus 13 divided by 2x minus 1 times x minus 3. So as we can see that the numerator is a quadratic expression and the denominator is the factorized form of the quadratic expression. So this is quadratic upon quadratic. So this is an improper fraction where the numerator's degree is equals to the denominator's degree. Where the degree of the numerator exceeds the degree of the denominator, such cases are not the part of your course. Such cases are not tested in P3 CAIE. Okay, so the improper fraction, the only improper case which you have is that the degree of the numerator will be equals to the degree of the denominator. So this is an improper fraction, and in order to break an improper fraction, we will break it like this, that first of all we will have a single term, a single constant a, and then we will see that what is the type of the denominator. So the denominator, both are linear factors. So this will be b upon 2x minus 1 plus c upon x minus 3. Okay, so a step which we are going to perform over here is that multiply this denominator on both sides. I mean, this is exactly an identity. Okay, so 4x square minus 13x plus 13 is equals to a times 2x minus 1 times x minus 3 plus b times, since this complete denominator is multiplied on the both sides, so 2x minus 1 and 2x minus 1 will be cancelled out, and b will be multiplied by x minus 3, and c will be multiplied by 2x minus 1, because x minus 3 and x minus 3 will be cancelled out. Okay, so as far as the cases of improper are concerned, okay, this constant term a can be just found within one step. Okay, this constant term a can be found within one step, that is the coefficient of the highest term in the numerator divided by the coefficient of the highest term in the denominator. Okay, so if we just observe the highest term in the numerator, that is 4x square, and the highest term in the denominator would be 2x multiplied by x, which is 2x square. So the coefficient of the highest term in the numerator is actually 4, and in the denominator it is 2. So therefore a is equals to 2. You can easily find the value of a in just one step. But remember that this can be only possible in the cases of improper fractions. So a is equals to 2. Okay, and then we have easily found the value of a is equals to 2, and then we are going to find the remaining values. So first of all, what I'm going to do is I'll just mention that a is equals to 2. I'm erasing this working. Okay, so now what I'm going to do is I'm going to make this a and b equals to 0. I mean, I want to eliminate a and b so that I can find the value of c. So for that purpose, I need to substitute x is equals to 3. When I substitute x is equals to 3, so 4 times 3 is square minus 13 times 3 and then plus 13. This is equals to a multiplied by 0, because this whole term is eliminated, and a we have already found. Okay, and b will be multiplied by 0 as well, and then c will be multiplied by 2 times 3 and then minus 1. So 4 times 3 is square minus 13 times 3 and then plus 13. This is supposed to be 10. And c multiplied by 6 minus 1. So this is 5c. C multiplied by 5. Therefore, c is equals to 10 divided by 5. C is equals to 2. A is also equals to 2 and C is also equals to 2. Now, in order to find the value of B, now since we had three unknowns, right? A, B, and C. A we have found, C we have found. Now you can take any value of X. I mean, the step which you performed over here, that you eliminated B and A by substituting X is equals to 3. You can also perform the step that you can take X is equals to half. If you take X is equals to half, so this C will be multiplied by 0 and this A will also be multiplied by 0, and you can easily find out the value of B. You can do this step as well. But since we know that we have three unknowns, A, B, and C, and two unknowns we have already found. So now you can substitute any value of X. But remember that use that value of X which has not been taken yet. So if you substitute X is equals to 3 again, so this same thing is going to happen, and then you won't be able to find the value of B. All right, so take such value of X which is not used. So easiest thing is take X is equals to 0. You take any value of X. Even if you take X is equals to 1825, 1825 भी ले लें आप, you will get the same value. You will get the same value of B. So I am taking X is equals to 0, but this is only possible when, for example, you have three unknowns and two are found and you want to find the last one. For example, there are two unknowns, one unknown is already found and you need to find the other one. But always remember to use such value which is not yet being taken. So X is equals to 0. So 4 times 0 square minus 13 times 0 plus 13 is equals to A multiplied by, since A is 2, so 2 multiplied by minus 1 multiplied by minus 3 plus B multiplied by minus 3, and then C is actually 2, so 2 multiplied by minus 1. So 13 is equals to 2 into minus 1 into minus 3. So this is positive 6, and then minus 3B, and then minus 2. So 3B is equals to 6 minus 2 minus 13. 6 minus 2 minus 13, this is minus 9. So 3B is equals to negative 9 and B is equals to minus 9 divided by 3, B is equals to minus 3. So A is equals to 2, B is equals to minus 3, and C is equals to 2. And then we have to express this in partial fractions. So 2 plus minus 3 hai. We have minus 3. So 2 minus 3 over 2x minus 1. And then we have C. So plus 2 over x minus 3. This is supposed to be your final answer. And this is question number 4.